Hello students, this is Mr. Downing. We're going to talk about some conceptual here with linear motion. Sometimes we will call this 1D, one-dimensional motion. This is motion just in one line, either forward or back. Forward and back. We'll talk about two-dimensional at a later time. So, motion is relative. Now, that means that we can't sense any motion. We can't detect it as a person unless we have something to compare it to. We can relate it to something else. If we can relate it to something else, then we know we're moving. If we're in a car and we're sitting next to our friend, even if the car is driving 60 miles an hour and we look at our friend, we do not see him moving. He appears to be sitting still relative to us. Even going 60 miles an hour, we can toss him a baseball and he'll catch it just fine. Even though us and that baseball is going 60 miles an hour, he's catching a 60 mile per hour baseball with his hands, no problem. Because we're all moving together. And when you think of it, wherever you're sitting right now watching this video, you and everything you can see is moving too. Because the whole earth is rotating, the whole thing is going around the sun. In fact, that whole thing is going around the Milky Way, and the whole Milky Way is moving too. But since we're all moving together, we don't have any sense of that motion. So even if you were in an extremely smooth car that was very quiet, so you couldn't feel any bumps in the road, you couldn't hear the engine, if you didn't look out the window, you wouldn't have any idea if you were stopped, driving 5 miles an hour or 80 miles an hour. You only know when you look outside and you can see something not moving, and you can relate your motion to it. So we always measure motion relative. Sometimes we'll call this kinematics. Kinematics is the study of how things move. So speed is the first quantity we'll talk about. It's a measure of how fast something is moving. It is a scalar. Scalar means that we only care about how much. We have a speedometer on our car. It tells us how fast we're going, but it doesn't tell us anything else. There's another term we're going to talk about in a second, a term vector. We'll talk about this momentarily. Vector also includes direction. Now, there's a difference between instantaneous speed and average speed. Instantaneous speed is at that very moment how fast you're going. Average speed is over a course in time. For example, you could be driving for 2 hours down a highway that has a speed limit of 60 miles per hour. If you drive for 2 hours and you end up 120 miles away, you could get a speeding ticket. Even though your average speed was, you did 120 miles in 2 hours, your average speed was 60, the speed limit. But that's not what they're measuring whenever the police officer scans you. Measure instantaneous speed. Because you could have gone 90 miles per hour for 1 hour, and then 30 miles per hour for 1 hour. Over 2 hours, that's still an average of 60, but you had different instantaneous speeds. So simple problem, speed of a man running 8 miles in 2 hours. Using this equation, velocity equals distance over time. Same thing for speed whenever we're doing the calculation, except the exception is that speed does not include direction. So we do 8 miles divided by 2 hours, 8 divided by 2, 4 miles per hour. Now remember that per means every. We're very specific on the words we use, so 45 miles per hour is saying that something moves a distance of 45 miles every hour. So there's 45 miles per hour, and 1 hour will be 45 miles away. So the units are very specific. Now miles per hour is what we use here in the United States. Most of the time here in physics we're going to use meters per second. But the units of speed can be any distance per time. Now velocity, we don't usually use speed in physics because direction is very important. So velocity is what's called a vector. So vectors are how much and which way. The direction's important. It's different if two cars are going 10 miles per hour in the same direction, one following the other, or if they're going 10 miles an hour towards each other and about to collide. That's different. Now, sometimes we'll be in a situation where we call constant velocity. That means our velocity remains unchanged. Constant. Changing velocity means it's not staying the same. It's changing. we call this acceleration. So acceleration is a changing velocity. It could be either speeding up or slowing down. So acceleration is not velocity. They are different ideas. Acceleration is a change of velocity. Now acceleration is also a vector, meaning it can be positive or negative. So positive would be speeding up, negative would be slowing down. Now if I go backwards one to my velocity, it can also be positive or negative. Positive just means forwards and negative just means backwards. So in physics, we're not using the positive or negative to count. We're using it purely to contain our information about directions. So a simple problem right here. A plane travels from 0 meters per second to 60 meters per second in 6 seconds. What is the acceleration? So we just do final minus initial. So every time we have this delta, so this is acceleration is the delta V over t, the change in velocity. We write that Vf minus Vi over t. So this delta change is always final minus initial. So 60 is the final, 0 is the initial. So 60 minus 0 divided by 6 is 10. So what is the average acceleration of a car that goes from rest to 85 kilometers per second in 10 seconds? Keep in mind, rest, that might not look for a number, but this is a code word for saying that the initial velocity is 0 meters per second. So keep an eye out for that kind of stuff. So we can set it up. Our Vf is 85, our Vi is 0, t is 10. Vf minus Vi over t, 85 minus 0 over 10, 8.5. How long does it take a car to slow down from 55 miles per hour to 45 miles per hour with an acceleration of negative 2.5? Keep in mind that the big number doesn't always go first, or the smaller number doesn't always go first. You always go Vf minus Vi. So this is my initial, and this is my final. So my Vf was 45, my Vi is 55, my acceleration is negative 2.5. Whenever I put that in, my time comes out to 4. Now, because acceleration and velocity are vectors, they can be positive or negative. Time is not a vector. It's only one directional. My time will always be positive. So a quick overview. Velocity is how our distance changes over time. Acceleration is the rate that our velocity changes over time. So if we look at our two formulas, velocity is a change in distance over time, and acceleration is a change in velocity over time. So acceleration is to velocity as velocity is to distance. It's important to keep these two quantities separate because they are both distinct but very important.